Hello everyone, uh, myself Arun, and today we'll be covering the EAGLE CAD part. Am I audible to everyone? Okay, so we will start now, and this is with respect to EAGLE CAD software, and basically this is about the designing of PCBs. So PCB stands for printed circuit boards, and you might have come across variety of PCBs. For example, the PCB that is in your mobile phone, or the PCB that is in the remote control of a TV, or similar things. So PCB is a critical component of many electronic devices, and designing PCB consists of multiple steps, and one such step is with respect to making a schematic, and then going toward the layout part. So let's begin now, and I hope that you also have installed the EAGLE CAD software. This is highly recommended that you install the EAGLE CAD software first, and once the EAGLE CAD software is installed, then we can go to the next part. So please open the EAGLE CAD software. You can do that by double clicking the eagle icon, and once it is open, uh, you can do the next step, which is first of all, so I'll also start with the recording part of the streaming. So let's start now with EAGLE. I hope every one of you is on this screen, the control panel. If so, let's proceed further. In the case of EAGLE, the main window is the control panel, and in the control panel we get the access to create a new project. Project will comprise of multiple files. The two important files of a project will be schematic and layout. So let's start by creating a first of all a schematic, and then proceeding with the layout part. So we'll click on file, then we will click on new, and then we will click on project. So once you click on project, this window will appear where there are multiple projects that you will be able to see, and these things are the name of the projects, and you will start by writing the name of the project. You can give it any name that is more suitable. So I have given it as NSUT test name. You can just after giving the name, just enter, hit the enter key, and then right click on the name of the project, then click on new, and then go to schematic. So if there is any issue with any of the part, you can directly ask the question in the chat, and then I can recap on that part also. So this is the first window that we are able to see. It is about the schematic part, and I hope every one of you is able to reach up to this window. Please confirm so that I can proceed further. Also, this lecture is being recorded, so if there is any issue, I will be sharing the recording link also, so that you can get back to the point. So this is our first window, and first part while starting the schematic or layout is setting the grid part. So we can do one thing. We will, as you can see on the screen, there is a icon named as grid, and we will click on the grid first. So these are the setting of grids that are being displayed. So we'll click on we'll set the display as on, and we will set the size as 0.05 inch will be our dimension, and in the alternate size we will select 0.025. So I'll explain what does size do. So size basically defines the grid size, what will be the minimum grid setting that will be used, and the alternate part is actually an intermediate setting of the grid itself. So if I press Alt, and then I can move in between the grid spacing also. So normally I will be able to move by 0.05 inches, but if required I can even go to the minute part, which will be 0.025 inch, and it will be accessed via pressing the Alt key. So this is the setting. I request all of you to set these settings. Once you do this, display should be turned on, and these are the settings, and then we will click on OK. So once you hit OK, your screen will display some kind of grids. Also all of you might be able to notice that the window that I have is appearing in black, and your window might be appearing in the white part. So how to change the color? It is a basically option that is given in the options window. Click on options, go to user interface, and then in the schematic part you can click on white, and if you click OK, then the window will turn white. So that is the thing, and I hope now it is common for all of us to have a similar kind of window. So this is the work area that we have, and here we will be placing the components, and we will be making a paper book type of schematic assembly of the components, and here are multiple options that are given. We'll cover each of them shortly, and then there are some other settings that are being provided here, and here are some tools that are mentioned on the left side. I hope every one of you is able to come up to this point, and all of you have also turned on the grid settings. So now let's proceed further. So what will be the first step? First step will be to save the schematic file, because we don't want the files to be get deleted by any mistake. So we'll first save the schematic. We will press Ctrl S, and once we press Ctrl S, or we can just hit the save icon here, and then we'll give a name to this schematic. So also you will be able to see that once the schematic is saved, the name changes here. It will not be untitled again. It will be whatever name you give .sch. So this will be this will indicate that your schematic is saved now, and now we'll start by populating the components in the schematic part. So we'll be making a basic circuit, and it will contain some IC, and it will contain some common parts that will be available in the EAGLE library. So as you are aware, there are multiple kind of resistance, capacitance, and other kind of electronic components that are available in local market, and all those components have a given symbol, and then they also have a given footprint. So symbol is basically a notation that we will be using in the schematic option of EAGLE, whereas the footprint will be used in the actual PCB layout, and it will be actual physical dimension of the component that we will be using in the board or throughout the final fabrication of the PCB. So let's get some of the components in this schematic. So I will now start with the add tool part, and while I am adding parts and while I am making changes in the schematic, I will go across various tools that will be necessary for you to control the EAGLE software. So let's start by clicking on the add part option first of all. So just click on add part. So once you click on add part, EAGLE will display a variety of libraries, as you can see. So basically EAGLE is maintaining a broad class of library where it contains multiple, this is preloaded, but you can also add your own libraries, and here you can see there are multiple libraries that are mentioned, and it will contain all the most of the required component. But if those components are not available, we can make our own library, or we can even import libraries that are available over net. So we'll do one thing, we'll start by importing an piece of resistance, and then we will proceed further. So for searching a component, there are multiple ways. You can just type in the name, and to search even finer or in fine details, we can use the star word asterisk symbol we can use, and then we can put the name of the required component. So since we require resistor, we will search for resistor part, and now you can see there are multiple libraries mentioned, and the most of the important library, one of the most important library that you will come across in EAGLE is the RCL library. So I would like all of you to remember this library. It is a critical library, and it contains most of the resistance, capacitance and inductors that are used in schematic and layouts. So we can do one thing, there are three options in the RCL library. One is REU, another is RTrim, and third one is RUS. So REU and RUS are basically similar kind of library, just the symbol of the resistance is changed. As you can see, this is the REU, and here the symbol of the library is given, or symbol of the subpart is given, and this is RUS, and this is the RUS symbol that is given. And RTrim stands for trimmer resistance, or basically resistance which have three terminals. So we will go to REU, and in REU we will be able to get various kinds of resistance. As you can see, also you might have come across a variety of resistance in your classwork, where you will be able to see that resistance are classified based on the wattage, or based on the process that is used to make them. So there will be multiple kind of resistance. For example, let's say 1/4 watt resistance, 1/2 watt resistance, 1/8 or 2 watt, similar kind of resistance. And based on the wattage of the resistance, the package is also fixed, that this package will be suitable for this kind of wattage, because a higher wattage resistance will require a bigger size, so the distance between the 2 points will be bigger. And in that sense, you can see that there are multiple kind of resistance that have been mentioned here, and I'll also explain what does this mean. Like you can see, for example, let's say there is a resistance where it is mentioned REU 0207/7. I hope all of you are able to see it. So basically this 02 stands for the distance between these two parts. Like what is the width of the resistance? As you can see, what is the dia, if you consider it as a cylinder, what is the dia of the resistance? It is 02 mentioned here, so it is 02 mm. The dia of the cylinder, or the thickness or the width, as you can say, of the resistance is 02 mm. Then there is 07 also mentioned. So 07 stands for the length of the body. So this, from this point to this point is the body of the resistance, and the length here is 7 mm. Hence it is mentioned as 07. and then again you can see there is a /7 also given. So /7 stands for the distance between these 2 points. There is a point here, and then there is another point here. These 2 points will be actually the place where the leads of the resistance will be inserted and soldering will be done. As you can see, if I go to another package where it is 0207 by 10, so the /10 value is changing, hence the distance between these 2 points are also changing. So this is very important, that every package of a given part means something or portrays something, and you need to take care of that while you are using any component, because there are thousands of components with the same symbol, but each footprint or package will have a different meaning. So that is an important and a critical part. So let's just click here. So we'll click REU 0207 by 10. We'll select, or we can select 0207 by 7. So we will double click here, and once you double click, you will be able to see this. I would request all of you to wait for a minute. I'll get back now. So we are resuming again, and I hope you have seen the part where we have added a part here, and how to redo it. I'll re-explain the part again. If there is any confusion, then we will be able to resolve it. So as you can see, first of all, there is a add part tool that we have. So we'll click on add part. We will search for the part that is required, and we will go to the appropriate library. In this case, it is the RCL library that we have used, and once we use the RCL library, then we will go to the part where we want to select a given kind of resistance. In this case, we have selected 0207 by 7 resistance, and once this is selected, we'll double click on this part, and we'll be able to insert it in the schematic. So once this is inserted, we can go and fetch other kind of components that are required here. So we'll if you want to go back to the add part tool, we can just press escape. So after pressing escape, we'll be able to go back to that part, and now we will be requiring to add some LEDs to this part. So we'll search for LED. So star LED star we have searched, and in this case, as you can see, there are multiple libraries that are available, and I hope you are able to find this library. It is named as LED, and in this case, in this LED library, since it is the managed folder is under EAGLE PCB, you all will be able to see this library because EAGLE itself provides this library. So in LED part, just go down and you can see there is a sub library named as LED. So once you go to LED, you will be able to select the LED package that you require. So generally there are variety of LEDs available. They are available in through-hole technology as well as surface mount technology, and in this case we have the general LEDs that we use are either of 5 mm, which defines the dia of the LED, or it is of 3 mm, which defines the dia of LED. So as you can see, this is a shape of LED normally, and if you consider this area, this cylinder, the dia of the cylinder is 5 mm, hence we are calling it as LED 5 mm. And similarly we have multiple kind of LEDs available, and then we have also have some SMD LEDs or surface mount LEDs, as you can see here in the picture. Those are also available. So let's just select our we'll select both kind of LEDs. So we'll select a 5 mm LED also, we'll insert it, and once we are inserting the LED, and if we want to rotate the position, we can just right click. If you right click, then the LEDs will be rotated, and if you left click, then the LED will be placed. So we have LED inserted a through-hole LED. Now we will insert a SMD LED also. So to insert a SMD LED, we can select this kind of package, as you can see. So 0805 is another standard kind of package that is available across resistance, capacitance and LEDs also. So this package also denotes the dimensions, and as you can see, if I double click on this, I'll be able to insert this LED also. So we have two resistance and two LEDs that we have inserted, and if I want to insert more, I can just keep on clicking, and Eagle will itself paste all these LEDs. So we can now press space, and let's also add some transistor also in this part. So we can do one thing, we will select or search for BC547. I hope all of you are able to follow up to this point. And I have a question regarding how to delete a component. So let's just do that part. So there is a dustbin kind of symbol that is shown here, and as you can see, if I click on that part, and also each component have a anchor kind of feature that as you can see, this part, if I zoom in, or for example if there is a resistance and I zoom in, I can see a plus symbol. So this is the anchor of the symbol that is available, and if I want to delete any part, move any part, rotate any part, I just have to click near the anchor point of that component. So it might not be very clearly visible in some components, but in some components like resistance, it is very clearly visible that there is an anchor point in between, and I am using if I click nearby, I can do the moving part, copying part, rotating part, deleting part. So just if you want to delete it, just go on the delete option and select any of the component. I hope your doubt is solved now, and let's proceed further. So let's just cover up some of the other options that are available in the left window. So first of all is the info option, and in the info part, we'll click on the info tool. As you can see, it is a symbol where it is says info or I in the circle, and if I select the info tool and I click nearby the anchor of any component, if I click here, I will be able to see all the details regarding that component. So it will have a name, it will also mark the position and gate, angle, device, footprint, all the details will be available here in this case. And once it is seen, so here we can also edit the name of the component if you want to, but we have other options also to change the name of the component. So we'll just click on apply, we'll click OK, and then there is a show tool that is available, but show tool will be more prominently usable while we draw the nets. Here also we can use the show tool. We'll click on show tool, and if we click on the part, any part, it will show the details in the status bar. Here at the downside there is a status bar, and it will just display the details of the selected component that is there. Then there is a group tool that is also available, and in the group tool we can just select two or more than two components. So let's say I want to move these two components that I have selected. I'll first select the component that I want to move. I have selected the component, then I will click on the move option. Once I click on the move option, I will right click here at any position in the window, and I will click on move group. So group basically consists of two or more than two components or parts, and if I want to do a certain kind of feature to multiple component, I can use the group tool. I hope it is cleared up till this point. And then there is a option of mirroring also that is available. So if I mirror any component, it will be rotated, or it will be mirrored via the y-axis. So here you can see that what mirroring does to a component, and the mirroring feature will also be available in the layout part, and there it will be a more critical feature than being used in the schematic part. Then there is a rotate feature, and this rotate feature can be either used like I can just click on rotate function, and then I can click near the anchor point of the component. That is one way of using the rotate feature. Or I can do other thing. I can click on move, and then I can click on the component, and then if I right click, I can rotate the selected part, or if I just move my cursor, I will be able to move it. So this is the feature that instead of using the rotate tool, I can simply use the move tool also for the same feature. So once it is done, then there is a copy tool that is available. I'll click on copy tool, and if I click on any of the component, then I will be able to make multiple copies of that component. So once I make the copy of the symbol, the same footprint is also copied in the layout part. Then there is a paste option, and paste option works with the group tool. So if I group, let's suppose I have grouped these two parts, I copy them, and if I want to even insert more number of copies, I can just hit paste. At any point, if I want to undo, I can just press Ctrl Z. And then there is the delete tool that we have discussed. Then there is a change tool, and change tool comprises of multiple options that are available, but they will be discussed later on based on the requirement. Then there is a add a design block option that is available in EAGLE. So basically this is an advanced feature that, or a new feature in EAGLE that was given recently, and basically what it helps in achieving is that if you are making multiple schematics and there is a common block that you use across variety of schematics, then you can just save that block or a group of or a part of schematic, and you can use that same part in multiple schematic. So let me just show an example. If I click on add a design block, and if I go to examples, I can see there are multiple listings that are given, that there is a option of adding a 12 volt voltage regulator that is given there, and here I can, if I double click here, I will be able to add it. So here since this is a part that I can use multiple times in variety of kind of schematics, hence it was given in the add a design block option, and variety of kind of blocks are available here which can be used. I'll just press Ctrl Z to delete that part. Then there is add part option that we have already covered. Then there is module and port option, which is not generally used in the case of EAGLE. And then we have or we'll be able to cover them later once we reach that stage. Then there is a net option that is available. So net option is basically used to draw connections between the two parts. So let's say I want to connect this end of the resistance with this end of the LED, so I will be using the net tool. Let me show you how to use the net tool. So I will click on net, and once I am nearby the connecting pin of the resistance or connecting pin of any component, it will be highlighted via a green circle, as you are able to see. So I hope all of you are able to see this and able to replicate this. So as you have seen here, and now I will, this is the resistance I am adding, just connecting these 2 points, and once I click here and once I click here, I am able to connect the two ends of the resistance with the ends of LED. So this is the way of connecting the components. So this is the part that we have covered. Then there is a bus tool that is available. So bus tool is slightly advanced feature, and it is used when we want to carry multiple connections from one point to other point. So let me give you an example. If I have a circuit where there are multiple connections that I want to carry from one point to other point, I will be able to use the bus symbol. I will also let me just check. I will be opening one of my schematic that we have previously made, and I will try to use that as a example. So I hope all of you are able to see. So this is a quite a complicated design where we have used a microprocessor and we have connected the memory modules or the memory IC, and as you can see, there is a blue line that is shown here, and this blue line is actually an example of bus where I am like there are multiple net, as you can see here. So instead of carrying all these net wire and routing these from here to here, since I want these to be connected here, I just let's say what a bus actually does in case of a normal life. Bus carry a large number of people from one place to another place. Hence similar is the case of bus in the EAGLE schematic part, where a bus is able to carry multiple signals from one point to another point. So here I have just created a bus, and I am able to add multiple nets on this bus, and then I am able to draw all these nets from the bus. So for example, as you can see on this bus, there is A8 net that is available, and then I am able to get the A8 bus A8 net out of the bus at this point. Although this is a slightly complicated feature, but the basic of the using of bus feature is that we want to carry multiple signals from one point to another point in a schematic. Then there is a joint function that is available, and joint is basically, let's say if I have two crossing nets in Eagle, but now you can see that these are not connected, and how to verify if 2 points are connected or not? We can simply use the show tool. So we'll click on show tool, and once we click on the show tool part, if I click on show tool part and then I click on the symbol, on the net part, then the 2 pins will be highlighted, the 2 connected part will be highlighted, and this another perpendicular net is not highlighted, which means that this net is not connected with this net. If I want to connect these two net, I can just basically select the junction part, and I will click on junction, and then I will click on the intersection of these two parts, and I will just select any resulting name of these two parts. So now if I use the show tool, if I select this net will also be highlighted, which means that these two nets are now connected. So this is the feature of show tool, to check the connect part between any two components or nets. If I want to delete the net, I will just click on delete, and then I can select the net also to be deleted. So up till this part we have covered, and then there is a label tool that is available. So label tool is basically used to show the name of any net that is available. So Eagle itself will start giving names to any net that is present, and if I want to show or elaborate, for example in the previous schematic that I have shown, there are as you can see, so there are multiple names that are given to multiple net that are present. So similarly I will be using the label tool to show the name of the net. So if I click on select label tool, and then if I go to the if I then select any of the net, it will highlight or it will show the name of the net. So once it is displayed, there are two ways of showing the label. This is a normal method, and then there is XREF on method also available. So it is a more beautified way of displaying the label. And then there is the size of the text that is displayed in the label name. So example, if I decrease the size will be decreased, and if I increase the size of the label will be increased. Then there is a ratio option that is also available. So if I increase the ratio, the thickness of the text will be increased, as you can see. Then there is a option of proportional also. So font option are basically 3 options that are available internally in Eagle, and there is a vector option, but vector option is not normally displayed. To display the vector option, we'll have to change some settings also. Otherwise only proportional option is available. So to change or to see the vector font, I'll elaborate later on. It is a simple way of going into the options and then changing the user interface. Now we will be able to see all the, so this font is actually vector font. I've changed back to proportional font, and now one more critical tool that we will be using is the name tool. I hope all of you are able to follow up till this point. So here is the name tool that we have, and once I click on the name tool, I will be give name to the components as well as nets. So here you can see R2 is mentioned in front of the resistance. This means that the name of the resistance is R2 currently. If let's say I want to change the name, and I want to give the name as RLED1, I'll be able to change the name also. So now if I go to info tool and I click on the resistance, I'll be able to see RLED1 as the name of the part, as it is changed now. Similarly, if I want to change the name of the net, I can just click on the name tool, and if I then currently it is N$1, but if I want to change, I can just name it as net1. So if I name it as net1, the name in the label will also change. Then there is a value tool that is also available. So value tool is basically, as the name suggests, is used to change the value of the component. So if I click on value, and then if I click on the component name or the component part, it will be asking me new value of RLED1, which is the name of the component that I have selected, and I can give it a value. So it will be a homework for all of you to calculate the value of this resistance. If I specify the value of the voltage that I will be providing, and what will be the, and if I also will be specifying the color of the LED, then you will have to calculate the value of the resistance. So let's just do this, and let's just specify some values, and then I would like all of you to calculate the value of the resistance. So I'll provide some details here. So I'm just giving some I'm doing some connections over here right now. I would like all of you to make these connections. So let's just label this, and label this with 20 volt, and label this with 5 volts. And if I label this as ground, so now I would like to tell you also about the color of the LED. So this LED, if I give it as the value as red, value of this LED is blue. So can you please share with me the voltage drop across a red LED, or the forward voltage or VF that is defined for LED, the minimum amount of voltage that will be required to turn on the LED. Can you share the details in the chat if anyone would like to? For a red LED and blue LED, what will be the minimum voltage that will be required to turn on the LED? And based on that forward voltage, we will be calculating the resistance, and then finally will be using the value tool to give the value to the resistance. Can you also mention for the blue LED? I have received one answer for red LED, and normally it is I think 1.8 volt that we take as an example. 1.6 volt is also okay, but normally we choose to go for 1.8 volt. So based on that, we will be calculating the resistance that will be value of the resistance that we will be using. Also, it is important to know the current that will be supplying to this LED. So normally the voltage limit the current limit that we give for an normal 5mm LED will be 20 milliampere, that we set as the maximum current value that we will like to go through it. Although we can limit it to 15 milliampere or 10 milliampere also, but we can go up for 5 milliampere. For 5mm LED we normally go for 20 milliampere. So based on that we'll be calculating the values of the resistance. And let's say if we calculate for a LED that is blue in color, and I want to pump about 20 milliampere through it, so I can do just one thing. I can calculate for it, and based on that calculation factor, so normally for a blue color LED where I have taken the voltage as 5 volt, the value will be around 85 as per calculation, but there are specific values of the resistance that are available. So I will go for either let's say I'll change the value to, let's say, 100 or 150 ohm. I will be using the value for a blue LED, and similarly I can calculate for this LED also. So yes, we normally take an value of 3.3 to 3 volts for the blue LED, and based on these calculations we'll be able to give the value of the component. And then there is an option of reposition attributes, and this is also a tool in EAGLE, and what it does is it helps to let's take an example. If by mistake I have deleted the name of the LED, I can not get it. I can either do a Control Z, or another way of showing the details of this component is by using the reposition attributes option. So I'll click on reposition attributes, and I will click on the resistance also, and then it will show the name again. Then there is a replace option that is available. So in the replace option, if I want to, let's say, replace the resistance with a bigger value, let's say, so normally we use 0 to 0 7 by 7, but if I want to use 0 to 0 7 by 15, I will select here, and then I will click on the resistance, and then I will be able to change the or let's say replace the component. So we just copied these two components, so details were earlier same, but since now I have changed the or replaced the footprint, so it says 0 to 0 7 by 15, and here it says 0 to 0 7 by 7. So this way we are able to replace the component. We can just go to replace, select our component, and then we can click on the required part. But if I go and select any other component, then it will show some error, because we are trying to replace user resistance. So our resistance can only replace a resistance and not some other component. Then there are some other features also available which are not of use for us in the current part, but there are some important features that are available. So one such feature is the invoke feature, and I'll show you how to use the invoke tool. So let's suppose I have added a component. Let's just search for 7400. So once I search for 7400, so this is basically an IC that I am going to use. And if I double click here, as you can see, this IC actually contains 14 pins, but I am only initially I am only able to get a package where only 3 pins are shown. So what about the rest of the pins of the IC? So to get the rest of the parts of the given IC, I can use the invoke tool. So invoke tool basically helps us in showing all the sub parts of a given package. So in EAGLE, mostly what happens is if there is a IC where the feature are replicated in the same IC. Let's say this IC that we have 7400 is actually a NAND gate IC, and it is a quad NAND gate IC, which means that there are 4 NAND gate in this IC. And since the features are actually replicated, there are 4 NAND gate, hence we have 4 such symbols in a given symbol. So to use the rest of the symbols, I can just go to the invoke tool. I'll click on invoke, and then I will click on the symbol that is present there. So now you can see that there are some symbols that are given where the sheet mentioned is 0, and here the sheet mentioned is 1. So this part where 1 is displayed is actually an OK part, and this part actually is shown here, but rest of the parts are not visible. So if I want to use any another part, I can just click here, and then I will be able to get that sub part of the IC also. Similarly, I can get the remaining parts also. So these are the powering pins of the IC that I am able to get, and these are the 2 NAND gate that are visible. So if I want to just use the 2 NAND gate, I can just complete my schematic using this part only, but in the footprint part all the pins will be visible. So I hope all of you are able to observe and reach till this point that we have covered in the EAGLE schematic. And then there are some graphic tools that are available. So let's say if I want to add a text, I can just click on the text tool, and in the text tool I can use to insert any text in the schematic. So one more important part that we can see right now, that every part has different colored scheme here. So the net is actually in the green color, the symbol is actually in red color, and then the name of the parts are in the green color, as you can see. So all these colors actually depict some kind of layers. So just to show the layer settings, we can go to the layer part and we'll click on the layer settings, and then it will be showing the layers that are currently available. So as you can see, if I turn off any of the symbols, any of the layers, then that layer will be invisible. So that is one feature of EAGLE. And then there are various layers that are listed. Normally we will be using the symbols layer, names layers, values layers, and info layers normally, and in some cases pins layers also we will be using. So let's say I want to delete this part, I'll just go to the group tool, and if I hit delete on the keyboard, this will get deleted. Or if I want to delete this group, I can just go to delete part. Let's just first select the group. I'll go to the delete part, click on the delete group options. So this part is I think is clear up to this part. Now proceed. Now you can see there are multiple graphic options that are available with us, but first we'll focus on completing the required schematic that we have in front of us. So we'll be adding some more parts, and this is important for all of you to see that how I am adding the rest of the parts. So let's say I search for a switch. So I have searched for a switch, and so let's say that we have used SMD special part of the switches. I will select this dip switch, because I think this will be all of you will have this library in your EAGLE. So I have selected this part. So I have inserted it in the schematic. So this is also a very normal kind of switch or push button that you will be using, and this is a 10xx switch that is very commonly available. I would like all of you to note this down. The library is named as switch omron, and I think all of you should be able to get this library in your EAGLE also, because this is a EAGLE made library. And we'll just double click here and we'll insert this also in our schematic. And other than that, since this is a circuit and we will be requiring some kind of connector to give the power to this circuit, hence we'll be using a connector also. So normally in the electronics industry there are multiple kind of connectors that are available. For example, your mobile phones normally have a type C connector, a micro connector, or a lightning port, that is or the Apple port that we say is present on the mobile phone, and that port is used to provide power to the battery and charge the mobile phone. Similarly, this electronic circuit will also be requiring some power, so we can either provide a battery on this circuit itself, or if we want we can just use some kind of connector. So normally the kind of connector that is used in the very basic electronics part is the Molex connector, and we'll be searching this using star M02 star. So star M02 star will be searching, and once we search this we are able to see that there are some connectors that have been listed, and we'll be using this. So we'll be clicking here, and this is a M02 connector that is very highly used in the electronics industry, and we'll be importing that also. So I hope all of this is clear up till this point. Now I will be deleting some of the unwanted parts. So I will be also showing you the main use of the label tool. So let's suppose that we have the net option available, and in the net option part I give the name to this net as plus 5 volt. So the name of this net is plus 5 volt, and the name of this net, as I will be giving the name to any net by using the name tool. So I click on the name tool, I click on net, and then I click on the give the name to the net. So once we are able to give the name to these two parts, let's just do the connection part also here. So one way of doing the connection is by just using the net tool part, and we can either draw a wire from this point to this point, and now you will be able to see that whether this is connected or not. I hope all of you are able to see that this is connected, and these two pins are highlighting when I am using the show tool, which means that these two parts are connected. One more way of connecting these two parts is by using the same name for the net. So let's say I draw a net also over here. To start a net, we can just start from any point. I started from this point. Then if I click, it will be able to revolve or move from that point, and if I press escape, I will be able to end it there. So now I will be naming this net also, and I will name this as plus 5 volt. So now it is saying connect this. This is given as the previous name of the net and plus 5 volt. So if I press yes, so now the name of these two nets are same, and if the name is same, then if I highlight one net, the other net with the same name will also be highlighted. So instead of doing a visual connection, we have just given the same name, and then the connection is also done. Similarly, I can do here also. I hope the naming tool part is clear for all of you. So now we have made the part of schematic, and as you can see here, if I highlight this net, the ground part is also highlighted. So I hope it is clear till this point. If there is any doubt, please inform. So if it is complete till this point, now we will be doing some more critical stuff, and one such tool is the net classes tool. So to access the net classes tool, we'll click on edit, and then we'll click on net classes. So basically the net classes tool is used to give some variance in the nets list that we have present, and let's say there are some wires that will be specifically carrying higher amount of current, or they will be requiring some special treatment in terms of the clearance or any kind of thickness that we want to let the eagle part know, then we can use the net classes part. Here normally default class is present, and in this default class all these are the member, all these nets are the member of the default class. Now I want to add a power class to this thing, so I'll click on add and I will name it as power. So if I name the net class as power, so it says no member this and member this. So currently there are no members, these are not the member of power class and there is no member in the power class. So if I want to add the ground in the member, I can just select the ground option and then I will click the arrow. So ground part will be selected. Then there is plus 5 volt option that is present, and if I select the plus 5 volt and then I click arrow, it will select the plus 5 volt option. So now plus 5 volt and ground are the members of power class, and default have these 4 as the members. Then there is a rules option that is given. So I will also mention the part of the width in the layout part also in greater depth, but normally as you can see that if I am fabricating the PCBs in house, or if I am using the toner transfer method to fabricate the PCB, the minimum width that I would like to set for any trace should be 16 mil. So mil stand for milli inches or thousand of an inch normally. So 16 mil is the standard width or the lowest thickness that I will like to get the net for any of the connection. Then there is power option, and for the power option normally we go for 24 mil at least 24 mil. We can go for higher also if the current demand for any given trace is higher. So there are also some online calculators that we can use to get the thickness of any trace that we are using, so that we can get the optimum thickness that should be at least present for that trace. Then there is a drill option that is given. So drill option is basically that once I am routing the board, these features will be more useful, and I will be explaining all these features there. Then there is clearance option. So clearance option is basically that between two non-same signals, what should be the minimum distance that should be maintained. So we can set that for a given class also. I will be using explaining these parts in depth during the design rule check part of the layout. So basically we'll be doing these two things, and then we will click on OK. So since now we have told the Eagle that we want to set two kind of net classes, one is a default class and one is a power class. Now Eagle will check whether I am using the specified values during the layout part, and that will be helpful for us. Another tool that we will be highly using in the schematic part is the ERC or electronic rule check. So we can use it by going to the tools part, click on tools, then click on ERC. So we have clicked on ERC part. Now you can see there are some errors mentioned. You can ignore the first error initially. This says that consistency not checked, which means that we have not gone to the layout part, and since we have not gone to the layout part, it cannot check the consistency between this schematic and the layout that we'll be making now. Errors are shown as 0, but there are some warnings that have been mentioned, which means we have to look into that also. So warning says that our LED has no value. So it is our choice to give the resistance value or not. but it is important for us to select the right package. So if there is no value, we can ignore it for now, but it is even better if we can give it a value, because this value will be a good reference for the person who will be soldering the board. So we can do one thing, we will be giving the value to this resistance also, and we will be calculating how much resistance will be required for the red LED. So we will be using, let's say, around 330 ohm for this red LED. Now we'll again go to the ERC part. Now it says S2 and S1 has no value, SL1 has no value. So basically we don't require values for these components. This is basically a Molex connector, and this is a 10xx switch that we have used, and there is no specific value for these components. So we can just click on clear all, we can ignore this, because all those things are now correct. Now let's say if I don't do proper connections, let's say I have opened this part, what kind of errors will be seen now? So now you can see that it has mentioned then this is a net N$1 that is present, but it has only one pin. Normally any net should have two or more than two pins connected, but it says only one pin is present on this net, which means that this net is not complete. Also, as you can see, there is another warning which says unconnected pin S1. Since S1 doesn't have a connected pin, or one pin connection is missing, so this is a warning, and we should take these warnings seriously, and we should rectify these errors. So just to rectify, we'll be doing one thing, we'll be making the connection using the net tool. And now if we again check the errors, we will to see that there are no errors. So basically there are some warnings that we can ignore, but there are some warnings which we cannot ignore, specifically the last two that I mentioned, that if net is not complete or any pins does not have any connection, then there might be some issue with your schematic. So you need to take care of that. And now we will be moving to some other parts. So once this schematic is complete, we can do some beautification part also, and in that case we can do one thing, we can go on the edit part, and then we can select the, or we can go to the draw part, and then we can select the frame option. So once this frame option is present, we can just draw the frame. So currently it is drawing in the net layer, but we would like it to use the guide layer instead of this. So I hope it is clear up till this point. So if it is clear till this point, let's proceed further, and now we'll be switching to the layout part, where we'll be making the connections between the parts. So let's this is an important part. Just click on the one more thing that I would like to mention in the schematic part first, is that we will be able to export bill of material. So So what I would like to show you, so normally bill of material or BOM is a critical requirement when we are fabricating or manufacturing the PCBs. So bill of material contains a lot of details, and I'll like to show you the details and how to get the details in Eagle. So we can do one thing, we will click on file and then we will click on export. Once we click on export, we will go to BOM. So please follow this. We have clicked on file, then we have clicked on export, and now we have clicked on BOM. So after clicking on BOM, I hope all of you are able to see there is a list that has appeared now. So as you can see, there are multiple parts that are mentioned, and these are actually the name of the parts. So this is the name. As you can see that we have used two LEDs, as there are two LEDs mentioned, and so forth. So all these are the details that are mentioned, and we can use variety of formats to export these. So let's say if I want to export this in text format, I can just save it. I am able to see this now. Now if I want to check this, it is saved here, and this is a normal format, the .txt format of the BOM, where these are the names, part names that are mentioned. As you can see, these are the parts, these are the values, this is the device, and this is the package mentioned for the parts that we have used. So these things are available now. Now let's move to the board layout part. This is a critical part, and this is the actual output that we are working on now. So we'll click on schematic to board switching button. We'll click here. It will show a warning that this board does not exist right now, and do we want to generate a layout based on this schematic? So we will click on yes, and once we will click on yes, it will show this kind of window. So now you can see what is displayed here. So here also it is important that you do the setting for the grid, and in case of grid, we'll click on grid, click on display, and wait a minute. So as you can see now, we will be first setting the grid option, and in the grid option we will be setting these two values. These two are the important value that we have. Size should be 0.05 inch, and alternate size can be this or it can be this, 0.025 inch. Please note this down. This is an important part. So we'll click on OK. Now you can see that grids are displayed on this window. Also I can change the color of the display. currently it is black, but I can use white also. And this is the these are the footprints that are mentioned. This bright colored area is actually marked by the yellow line over here. As you can see, this is the boundary or the dimension of our PCB, the rectangular PCB, that the maximum area that is allowed to us. So now we can do one more thing. This is our design, and here we'll be adding the component in a given fashion to make some appropriate connections. And one more critical thing that I would like to mention. As you can see, we have set the size as 0.05 inch. So why is it 0.05 inch? There is a particular reason for using this 0.05 inch number, because normally or initially most of the components used to have a spacing, or most of the connectors used to have a spacing of 0.01 inch. As you can see here, this Molex connector have a spacing of 0.01 inch, and since we would like to move intermediate also, intermediate movement might also be required, hence we have used the 0.05 inch option as our grid setting, so that if we want to move in between the pins, we can use the lower setting of the grid to make that happen. So as you all have noticed, normally in any kind of electronic circuit or part, the connectors are usually placed on the edge. For example, your phone, your laptop, or any other kind of thing that require external power, we will have the connector normally placed on the on any of the edge as per the usage or ergonomics that we can say for. So here in this design, we will be actually using or placing the connector on any of the edge, and we will be taking the help of the schematic also to make the placement of the components. But there will be some critical rules that will apply and that we should adhere. So we have added this connector, and let's take a look at our schematic also. So in our schematic, we can see that the input part or the input connector is on the left side. Then we have the two switches, then we have resistance, LED, and then the rest of the part. So similar kind of placement can be done for the components also. So let's say we have this switch present and this switch present. So now I am just generically placing the component. There is no fixed thing that I want to do. It is just a normal placing. I can do multiple times. I can move the components. So here is the move tool that is present. And also one important or critical thing is based on the EAGLE version that you have. So if you have a free version, then free will be shown here, or offline will be shown here, and based on that there will be some limitation on the kind of PCB that you make. There will be some limitation in terms of the size of the PCB, and then there will be other limitation in terms of the placement of the components that or the component placement that you can normally have. So in your case, if it is a free version, then you might not be able to use any other area than this space. So there will be some space mentioned, and if you try to move the component in the negative space, or let's suppose this is the x-axis and this is the y-axis, then only positive x and positive y space will be permitted for the movement of the components. No other components movement will be allowed. So in the case of layout also, there is a anchor symbol that is present on every component. As you can see, there is a plus sign that is present, and this anchor sign is important for the movement of any component. So if I want to move this, I will just click here, and then I will be able to make the changes. So once this is done, now we can re-verify from the schematic, and also we can look that there are some yellow wires that are drawn from one point to other, and while placing any component, it is a good practice to minimize the crisscrossing between the parts. Although it may not be always feasible to do this, but normally it is better if you can minimize this crisscrossing. So let's just go and see. Let's say for example, as you can see, this resistance have a connection from this point to this point, so it is better to move these resistance and make the connections appropriately. So I will just move these components. So moving is simple process. I can move by using the move tool, and if I want to rotate the component as required here, I can just right click to rotate it. So I right clicked and I am able to rotate this. So now we have done the placement of the components. So one more important part with respect to the placement of component is that we should be placing some of the holding holes or the support screw holes on the PCB. So we should make space for those also, just as I will be showing you. as you can see, here we have a spacer connected to a PCB, and this is basically a kind of a standoff that is provided to increase the height of PCB from the any of the board or the part that we will be placing it on. There should be a minimum gap that should be maintained so that the component beneath or the soldering beneath will not get shorted due to the placing of any metal part. This will basically increase the height of the board. So similar standoffs should also be provided in your PCB, and what we'll be doing is we will be adding those standoffs here. So to add the standoff, there are multiple options available. We can either give a normal hole, which will be of 3 mm. Basically, normally the standoffs that are available have a screw and a hex in it, and the screw is of size of 3 mm. So 3 mm hole need to be provided in the PCB, and that will act as a standoff for the PCB. So we can do that just by going to the hole part, and in the drill part, currently the dimensions are in inches. You can see here inch, so the dimensions are actually in inches, and we can change these dimensions by selecting mm here, and then we can get a good reference that currently what drill size is being used. Currently the drill size is 0.35, but we can go to the we require a 3 mm hole, so we'll select 3, and now you can see that a 3 mm hole is present. So although this part can be done later on also, the addition of support screw, but in some cases the placement of holes is fixed, and we have to first place the holes based on the casing that we will be using for our PCB. So next step for us is to make the connections, and currently if you want to see that the placement is okay or not, you can just click on the rat's nest option. So once you click on rat's nest option, this view will get modified, or the shorting or the crisscrossing will reduce in some way, and if it get reduced, this means that the placement is much more better now, and basically it gives the connections to the nearest part. Once you collect the rat nest, the nearest point to which the signal should go, the wire will be connected to this part. So this yellow part is actually the unrouted layer that you are seeing currently. The next tool, these tools you are familiar with, the info tool first of all. So info tool, basically you select and you click on any of the component, and the name and position and other details of the part will be displayed. Then you have the show tool. Show tool is basically, if you let's say you use it on any component, the detail of the component will be highlighted here. But if you use it on any of the unrouted part, then it will highlight all the pins that are shorted. So that is one part. Then there is a group tool, and group tool will be used to do some modification to 2 or more than 2 parts. So let's say I want to move these 2 parts, so I can just click on the group tool. I think the second resistance was not selected, So I have to cover these two parts first of all using the group tool. Then I can go to the move tool option and I can just move these two as per requirement. If I press escape, then they should be relieved, and then there is a mirror option. So this mirror option is critical in the case of layout, as I will be showing you. So currently all the components are on the top side. Top side means the current view that you are viewing the PCB, the parts, all the parts are inserted from the top and then soldered on the bottom side. So there are two sides of the PCB, and I will be using the feature of EAGLE itself to show you what the two side of PCB means. So if you have done the placement of the component, just go to the manufacturing option, click on the manufacturing option, and once you click on the manufacturing option, EAGLE will show you two parts. Or let me just decrease the size of PCB first, then it will be visible in a very better way. So here I am decreasing the size of my PCB. I am using the move tool, and then I am selecting any of the edge to move the edge. This is one way of reducing the size of PCB. There are other ways also that I will be mentioning. So now I have reduced the size. Now let's check the manufacturing part. So now you can see that there are some connections that are displayed on the top side, but some connections will not be displayed on the bottom side. For example, these two parts, as you can see, these are pads, but they does not contain any hole, and neither does this pad contains any hole. If I go to the bottom side does not contain those pads. First of all, neither they contain any of the marking. These white markings are not present on the bottom side, as you can see. So basically, if you are seeing the PCB from the bottom side, it will look like this, where the through-hole component will be inserted from the top side and they will be soldered here. But the SMD components are actually installed on the top side only, and then they will be soldered here itself. They will not be soldered on the other side. So this is the difference between the normally surface mount components or SMD components or SMT components and through-hole components. I hope I am clear till this point, and now we'll be proceeding with the layout part. So first of all, what we are going to do is with respect to the single layer routing and how single layer routing is done. So single layer routing means that all the traces or most of the traces are present in a single layer and not any other layer. So normally the routing is done in the bottom layer. So bottom layer is the layer which is present on the other side of the PCB. Here we were able to see two sides. The traces which are present on the bottom side, these traces we are going to make now, and you will be able to see the changes also. So one thing that we can do, and that was I was going to show you with respect to the mirror tool. So just click on the mirror tool. Once you click on the mirror tool, then you will be clicking on the component. So if I click on this component, the color of the pads will be changed. So red color determines the top side. This is very important for all of you to note down, that red color determines the top side, whereas the other side or the bottom side is determined by the blue color. So if I mirror this part, it means that the component is now shifted to the other layer. So earlier it had red pads, which meant it was on the top side. Now it is on the bottom side. As you can also see in the manufacturing option, that if I go to the top side, that component is not visible, but in the bottom side that component is visible. Similarly, I can do for the LED also, the SMD LED that we had used, and now we can easily route the components in the bottom layer. So this is another part that is with respect to the routing. So before routing, there is another tool which is rotate tool. It works similarly as was in the case of the normal tool that we had used in the schematic. So if I click on this rotate tool, I can rotate the components, and then I have the align tool. So align tool is basically used to align two or more than two component with the, let's say if I want to align this these two resistance in a way that the left side is at the same point or in the same x length, I can do just one thing. I will select these two resistance. Once I select these, I can go to the align tool, and then if I select the align left edges option, the left edge of these two component will be aligned or will be at the same x length. If I select the, let's say, align top edges, then the top edges of these two will be aligned. So these are the top edges, and now they are aligned. Similarly, there are multiple options available, and we can use as per our requirement. Then we have the copy tool available, and copy tool basically will not be working here, and majorly because EAGLE works on the factor that once you should do such kind of changes in schematic itself and not vice versa. Changes in layout are not allowed in terms of component deletion or component addition, as well as copying the component. So if I try to copy this and I paste this, it will say cannot back on it this operation, which means that this operation should only be done in the schematic part and not on the layout part, because changes made in the schematic are reflected into the layout, but the layout changes cannot be reflected back into the schematic. Similarly, delete option will also be not used there. Deletion will also should also be done in the schematic part only. Then there is change option, and change option will come back to it. Rotate tool can be used to minimize this crisscrossing. So currently this is crisscrossing, but if I rotate this, then the crisscrossing will be removed, as you can see. Similarly, here also the crisscrossing can be removed by using the rotate tool. So this is done till the point. Now we are on an important feature that we will be using. It is the route airwire option. So route airwire option works in this way, that I click on the route airwire, and then there are multiple options that are available. First, let's go through these options. Also, I will be switching the grid back to the inch option. So with respect to the route airwire option, we will be routing or connecting these parts by by copper strips or by copper, and we'll be using the route airwire to make the connections. So normally, for all of you to note, I would like all of you to note some important features that we have. First of all is the width part. So width of copper trace, so normally the width of copper trace or copper track should be default setting should be whereas the power traces should be at least 24 mil. So I am mentioning these values, but these are specifically for in-house fabrication or for the toner transfer method. I am mentioning these values. For PCBs that are fabricated outside or by some outside fabricators, lower values can be used because they facilitate lower tolerances value, and they have their own set of values which you can get from the website. And I will also share some details here, like how to check that what are the details or the limitation of any PCB fabricator. So let's say I am going to I have gone to a website. It is a normal website where we upload our PCBs for fabrication. So here, as you can see, in the manufacturing part there is an option for technical capabilities. So in the technical capabilities part, here it is mentioned that how various inputs are required or various limitations are there in the fabrication method. So you can read these values, and based on that you can create your PCBs, and then you can send them for final fabrication. So I hope you have noticed these values. Then another value is with respect to the drill. So normally the drill size should be at least 0.9 mm or 1 mm. This is the minimum drill size that you should have in case of vias. I will also explain the function of via now, but please take a note for these values. So let's start by routing part first. Click on auto route or the normal route airwire option, and then click first of all notice these settings. So currently the routing option says that layer is the first or top layer. Rather than this, we should go to the bottom layer. So in the bottom layer, the trace will be on the bottom side of the PCB, which is the normal process that we do for in-house fabrication. Or the single side PCBs are normally routed with the in the bottom side only. So this is the one part that we have. It is with respect to the layer. So first we will select the layer. Then there are three options that are available for routing. I'll give you example also. Like first of all is ignore obstacle. So in case of ignore obstacle, you can route in whichever manner, and EAGLE won't provide any assistance in the routing part. Another option is walk around obstacle. So if I now try to go above any of the pad which were not initially required, then it will not allow the routing over that trace. So it will just not allow you to route over unwanted areas. Then another option is with the push obstacle. So in case of push obstacle, Eagle can either push any components that is in the path of routing, but that is normally with the other kind of components. So so 90-degree routing is not recommended. Normally we go for this 45-degree angle for routing, and then we have the option for the width. So normally the width will be 0.016 inches, but since we are routing the power traces, we will go for 0.024. And similarly we will be doing the routing part. Uh, so currently we will be pausing this part, and we will be continuing tomorrow with the rest of part, since I think it has been almost 2 hours since we started the class, and there are multiple things that I think you all would like to first do yourself and then go about it. So it is better that we pause it for now, and we will resume it tomorrow at 3 p.m. as per the schedule that was provided. And I hope then it will be even more clear, since you will be getting the video recording today for this session. So I think you can repeat or redo some of the part by yourself. You will get some better hands on, and then it will be more beneficial for you to come tomorrow and observe for yourself and do all these parts. So tomorrow we'll be completing the routing part, the design rule checking part, and some other critical feature, as well as how to go about the in-house fabrication. I hope I am clear. Am I audible or not? So we'll be resuming tomorrow, and tomorrow we'll be completing the routing part, the design rule check part, in-house fabrication consideration, as well all other errors that normally occur in your PCB. So let's just connect tomorrow at 3 p.m. We'll be sharing the link again for the live streaming. Thank you all for your participation.